In this video, I'm going to share about the MATLAB system identification toolbox. So open your MATLAB. You can access your system identification toolbox apps from apps and system identification. So this is your system identification toolbox. So assume that you already have the data. Here I have time domain data. The raw data is this one. PCT107 heat transfer eqdata.mat. So .mat file, meaning it is in MATLAB format. So for the system identification, we going to use the hot water pump.mat file as the input, and the tube outlet estimate normal.mat as the output. Okay. For system identification, we are more interested on the hot water pump data. So this is the hot water pump data. This is from the data from P101, the status of the pump. And this one is the tube outlet temperature data. We're going to use the tube outlet temperature data as the output of the control system, and the signal or the status of the pump as the input of the control system. For hot water pump, this might confuse you a little bit, but to be more accurate, to be more precise, we're going to look at the pump behavior, pump output behavior, which is P101 is actually the manual value for the control valve CV101, and we're going to use this particular signal as the input of the control system. So from system identification toolbox, you can see that we have few parts. Okay, we have few parts. Choose time domain data, and then we have the time domain signal. A pop-up will appear, import data, time domain signal, and then input. So our input is basically the hot water pump, okay, and the output is the tube outlet estimate normal. Okay, first we have to load both data into our workspace. So close this one first, and then load into workspace, and then load the tube outlet estimate normal into workspace. Come back to the system identification toolbox, go to import data, time domain data. The input is basically the hot water pump, and the output is tube outlet estimate normal. So the data, we're going to generate the data and name it as a my data. Start time is 0, sample time is 0.5, because our sample time in our experiment is 0.5. You can click more. So we have just this one, just put it as default, and then click import and close this dialog box, and this is our data. Okay, we can have that, we can click the time plot. So from time plot, y1 is the output data, u1 is the input data. So we can see from here, this is the pump signal, and y1 is the tube outlet signal. Both of the signal has been normalized from value 0 to value 1. Okay, and then we can estimate the transfer function. Okay, we can estimate the transfer function. Just click this one, estimate transfer function model. Okay, the dialog box will appear. So from this dialog box, we're going to develop, or we're going to process a transfer function. We name as a transfer function model name as a TF1, transfer function 1, and then we're going to play with the number of pole and number of zero. So for example, this one by default it is number of pole 2, number of 0 1. We're going to have the continuous time transfer function, and then we go to estimation option. Okay, this is the setting, display progress, just put it as a default setting. Estimate covariance, just put it as default. Go back to the model structure, and then go back to estimate. Okay, we can see that the identification progress, transfer function identification, estimation data, time domain data, my data. Data has one output, one input, and 3,603 samples. And then number of pole that we put in the setting is 2, number of 0 is 1, initialization is IV, initialization is 5, and then estimation progress, and this one is the estimation progress. Initializing model parameters, initializing using IV methods done, initializing complete algorithm, non-linear least square with automatically chosen line search method. So this is the iteration. So we have iteration 0, iteration 1, iteration 2, and iteration 3. This is the cost function, and then this is the normalized of steps. First of the optimality, improvement expected number of achieved, and this is by section. Estimating parameter covariance is done, and then you can see that the original output is on the gray line. This is the data y1, and the model is on the blue curve. So the model fits about 55.45%. So the fit to estimation data is about 55 to 45%, and the FPE is 0.00545618, and status estimated using TFAS. TFAS is basically transfer function estimation. Okay, so next we're going to look how can we display the transfer function equation. So this is the transfer function equation. The model output. Model output is basically the transfer function. Sorry, the curve itself, the curve that we display earlier. Okay, and then we can put this TF1 into workspace. Okay, so we have TF1 here. If you look at the workspace, we have TF1. Just drag the TF1 to the command window and then press enter. And then we have, this is the transfer function. Then this is the transfer function. So that is the transfer function, okay, with the number of pole 2 and number of 0, 1. Okay, so that's all for this time. Thank you for watching.